All right, guys. So let's start. What we're gonna do today is installing Go. We're gonna install Go, and maybe we'll try to write a web service in Go if we have time.
Okay.
So let me share my screen. Do the entire screen. Share. Move this guy out of the way, and I'm here. So this is the Golang website, and you guys can stop me anytime you want and ask questions. Okay. Anybody here know anything about Go, or did you guys heard about the language? What do you guys like? What's your knowledge about the language?
I just heard about it.
I heard Go was dead.
I heard it from you. That was it.
So Node.js died and Go killed it, according to me. So Go is a programming language that was created by Google a few years ago. The people who created Go actually are people who built Unix. So it's pretty hardcore group of people, very opinionated bunch of people, and they really took the Unix philosophy and they show it in the language. It's very, very simple language, maybe one of the simplest one. Only 25 keywords, which is less than C, I believe. It's compiled. There's one formatting. There's a command called gofmt. You run it, and that's it. That's the formatting of your code. So there's like no question about formatting, you know. So there's unlike JavaScript, we have arguments about semicolons and tabs versus spaces. That's gone, you know. There's just one way, and it's the way that the Google guys decided to put in the language or in the tooling. So other than compilation, it has a great way to achieve concurrency. You don't need to use callbacks anymore, like JavaScript or Node. Use something called channels. So you basically create a channel, and you can pass a channel into your thread. And thread, it's called a Go routine. It's a little thread. It's very, very lightweight thread. It's like 2-3K in terms of memory. So you can just write the Go keyword before your function call, and that's it. Do Go space and then foobar. Foobar is a function, and then your foobar is running in a separate thread. And the way to communicate back and forth between your main function and the Go routine is via this thing called channel, which is similar to Unix pipes. Which if you don't know what Unix pipes are, it's okay. Maybe later on, maybe next week, so we're gonna have more sessions. We'll talk about this, but it's a pretty cool way to achieve concurrency without breaking your brain to pieces like Node.js or JavaScript. So we need to install Go because we don't have it on the server. So you go to the main page and you have documentation here. Everything is cool so far. You have questions, guys?
No.
Installing Go, getting started. Okay. Okay, let's go to the website here. Download Go. So the last version is 1.6.2. So I can just go and install it. You have multiple operating systems, even on Windows, on Linux. So I'm gonna do wget. I'm gonna just do it from the command line. I have the script somewhere here. Here it is, wget 162, right? Let's change the script a little bit. Can you see? It's pretty tiny, huh? 1.6.2. Yeah, 1.6.2. Okay, 1.6.2 here. That's about it. So first, user. I don't care about this. Okay. This is our server. Wget is a command in Unix or Linux to grab stuff from the server. And I'm going to use the tar command. 1 second. Oops. I don't remember the password. Give me a second. I need to log in the different user. Give me a second. Do it like this. I have to get out of the server and connect again. 1 second. You gotta be super user to do this stuff. Basically, what I'm saying is I want to put the Go executable inside the user local. So I think if I do the Go, yeah, I have the Go command now. Let me just exit here and access the session again and join it with Tmax. Okay, you should see me now. Interesting. Maybe I'm going to be installed as this user somehow. Okay, let me try. User local, put it somewhere else. This command. You see me, what I'm doing? Hey, is anybody there?
Yeah.
Oh, sorry, I'm not sure if you're still here. So yeah, just using different user. I never used this user here, so no, I don't have sudo guest. I should have gave guest sudo. Okay. Here. Okay, so yeah, I have Go. I just put it inside like a folder that is accessible to this user, the guest user. So basically, let me see here, bash rc. I probably need to do something with this file here to tell it where to find the Go installation. So Go binary. Let's edit the path. So I'm gonna do. Home guest Go bin, I think. Right? Go bin. And let's do. Sorry guys if I'm doing some weird stuff, but echo path. I'm trying to add this folder.
$sign path.
Thank you. You see the new one that I created or no? Not there, huh? Oh, I guess I need to do something. It's not like
$sign path and then colon slash home.
You're right. So I think I need a colon, huh?
Yes, $sign path and then colon. Yeah.
Thank you so much. Okay.
Go back again. Let's go back. Look at the bash C file.
Okay.
And it should be path, not go path. That's path. Go path. Yeah, path equal. Yeah, like that.
Yes.
No $sign for the front. No, I think no $sign. Let's try.
Thank you.
Yep.
So we have Go installed. Normally it's going to be fairly easy because you're going to have super user. So I don't have super user access to this guest guy, which I can change, but normally it's going to be fairly easy. You just install it and you have Go, right? Make it even easier. So yeah, so you can see the different commands that Go gives you. You see FMT, which I mentioned before, formatting. We're going to use the Go build to build it. Where's the build? I don't see Go build. Weird. But anyway, so let's write our first Go program, right? Let's do Hello World Go. So let's do mkdir Actually, before I do it, I need to create workspace. So Go work, the way it works, you need to create your Go workspace, and that's where anytime you go and install package from the internet or all the dependencies that you get from the internet, everything you work should be work inside a workspace. Okay? It's all documented on the Go website. So if I go here, go back. I don't see anything about workspace. Did I miss it? Yeah. Yes, basically you need to create a workspace directory with a bunch of folders. So I have a little helper file here. Make deal. Okay. Let's copy this line here. So let's say let's call it workspace. I guess I can call it workspace. Space. I don't know how to call it. I'm not very creative right now. I'm gonna say here it's gonna be workspace. Okay. So you can see that in workspace I have those 3 empty folders, right? And now I need to tell the Go in the bash RC where is my workspace. Let me see here. Go path, go binary, all those guys. Copy those guys. Go path is in here. Go bin. Wait, go path. Maybe that's sorry. Maybe that's the workspace. I think so. Go binary is probably this guy. I don't need this one anymore. Okay, that's it. Now let's go to a workspace. So anything I'm going to work on is going to be inside the workspace, right? SRC. I need to create. That's my GitHub name is Oren. I think so. Let's see if I document. Yeah, I did document it. It's here.
Don't you need to source the bash RC first?
Yeah, it's not a bad idea. Okay, now I need to create a new directory called github.com and then Oren. Basically, that's how you start your workspace with this kind of structure. And it's important because the way it Go works, there is no like npm or Ruby Gem. Like there's no like a special repository of where you can grab things where you can grab like packages and libraries from the outside world. It's just on GitHub. So everything is kind of namespace. So if you're going to grab something that somebody else has wrote, Go will create the folders, and it would be like github.com. Then the username might be Kuba, and then whatever Kuba packages I'm using that belongs to Kuba. You'll see it later on, so don't worry about it for now. But so anything I'm working on, I'm gonna go in here inside Oren, because that's my name on GitHub. Let's create our server, right? Let's call it Go server. Hello world. It's not going to be a server, it's just going to print something to the screen. So I'm going to go inside, get a file called main.go. It can be whatever, as long as it has like extension Go. I don't have my text, my Vim text highlight, so it's going to be a little bit ugly. Go package main. Let's just copy from the website, Hello World Go. There's a Go tour, which I highly recommended. Go tour is like a way to learn Go. Let's copy from the Go tour. Let's copy, and you can run stuff here. So if you click on run, see, it actually runs stuff for you, and there's an entire tutorial that you can kind of like go through to kind of like get started. Over here. Okay. That's my terminal. It's stupid. Okay, and I'm going to go here. I open the little split screen. Do it with Tmax. Now I'm going to run the command go build. Actually, inside. Go build. Okay, notice that now I create this binary. The binary, in this case, it's 64-bit. But you can actually pass an environment variable to the build command. And if you want to build a different architecture, let's say your server is not a Linux server, so it's not going to work, right? You need to, for example, I had to deploy once on a Raspberry Pi. So you need to give it like an ARM architecture. So yeah, and the nice thing about Go that it's like a binary. That's it. That's all you need. So if you want to like deploy your code, you can literally secure copy STP or just copy it to your server. So the way to run it, you just run a binary. Hello, it's supposed to be probably ni hao in Chinese, but in my case, my terminal doesn't support Unicode. I guess I'm not sure. Let's change it to world. Then I'm going to save it. I'm going to run the Go build again. And now it says hello world. Yeah, that's kind of like hello world. And it's basically create a binary for me, and I'm just running it. I can also run the go run command if I don't want to build it. Just do run and then main. And to do the same stuff without creating the binary. So, you know, for testing, sometimes you just have one file, you can just run it. The Go build will actually look at all the Go files in their current folder, and it will take all of them, and it will build an executable. The Go run will not. The Go run is just for one file.
What if you have a multiple Go file, like in C, you can have a lot of function. Do you need to write a makefile?
You don't have to write makefile, but you can if you want to. If you have more stuff that you need to do, so yeah, definitely use a makefile if you want. But you don't need to. Every Go program, by the way, has a main function. If it doesn't have a main function, it means that what you're building is not an executable. It's a library. Okay, and the library doesn't have a main function. And if you have multiple files in one folder, only one of them can have main function. You can have two. Go will give you will complain. And right now, I'm not even using any syntax highlighting, and there's an amazing plugin for Vim called Go Vim, I think, or Vim Go. And maybe I'll show it to you next time. But doing a lot of stuff for me, it can tell me. Let's say I'm using something here. Let's say I'm changing something here. Let's say I'm using a library, right? Like math library, you know, math dot whatever, some function, right? It will go and automatically add the correct import. I didn't mention what import is, but import is like I want to require, you know, separate external library. In this case, FMP and math are in the core library, but I can import somebody that somebody wrote. So I can do, you know, .com, Kuba, something like this. I can import from other people's libraries. So the Vim plugin, there's also plugins from Atom and other text editors. So the Vim plugin will know to just add the right imports for you and remove them if you need to. Also, GoFMT, I didn't tell you about GoFMT, but if I'm running GoFMT, it will see what happened? It added up spaces here. It formats the code for me, so it's pretty cool. And also the Vim Go plugin do it for you every time you save the file. It will do the formatting for you, which is super nice. I just didn't bother. I didn't prepare well for this session to install everything, all the Vim plugins. So yeah. Any question about Hello World?
So the binary you compiled, it can only run on that architecture, right? It cannot. You have to recompile for other architecture.
Yeah, in my case, I'm using Ubuntu on the server that we're on. It's like on DigitalOcean Ubuntu, so that's pretty cool because it's going to run on my production environment, assuming that you're using Linux. But if you're on a Mac, you probably need to before you deploy to your production, you need to change it to 64-bit.
So you have to do a compile, right?
You just need to change your in the go build command. You need to give I don't remember the exact let's go for it.
It's like a C binary, or it's like a Java like bytecode.
It's a C binary.
Okay, so I think you do have to compile for different platforms, like Mac. You have to recompile.
Yeah.
Okay.
So you see the Go architecture. So you need to like give it this this environment variable, and then you can run your So I think that's what you're gonna do. You can choose whatever. This is 386, right?
All right. Okay.
So yeah, it's pretty cool. It's pretty cool. So yeah, let's try to build a web service. We're cool. Web service. I'm gonna go and just go to my GitHub because I already have a bunch of stuff I experimented with Go repositories. Go. Okay, let's take this guy here. Hello world or. Okay, let's copy this. So we're gonna keep our hello world, right? But we're going to create a new folder. Let's remove the hello world. Or we can create a Git repo maybe and put it on GitHub so people can see it. So let's create a hello web service. Main.go. I'm going to paste this. Because the fonts, let's remove the other guy for a second so you can see what's going on there. Let's see it. Okay. So notice that here I'm also importing. Notice that now I can do this. I can import multiple libraries, right? And I can use this parentheses here. Import multiple instead of like line by line. I can save. I need to write the import name again and again. And I'm using IO and netHTTP. Well, again, we have the main function. Now we have this interesting function. So HTTP, where is this coming from? It's coming from here. Mm-hmm. That's a convention in Go. So the last, this is the folder net, and then they have HTTP, right? So I can look it up, the documentation of this stuff later. And because that's the last name here, that's going to be the name of that you can use, right? So HTTP here. And inside HTTP library is a bunch of functions, one of them called handle func. So that's like a built-in route in Go. So basically I'm saying every request to my root, call this anonymous function. Okay, so in Go, this is like calling a function, right? Handle function. This is the first argument, it's a string. Second argument, it's a function that accepts two arguments. The first argument is of type HTTP response writer, and the variable is W. Second argument, right, is HTTP request. Notice that there's a star here, right? That Go has pointers, which doesn't really matter right now, but just remember that you see stars means that there's pointers involved in memory. And then R is the name of the variable. So basically, it's kind of like Node.js. I don't know if what's your background and but in Node you also have it a response and request object that are kind of like every request that you have those guys. And this line here is like I'm using this IO library and I'm doing write string, right? So what I'm doing, I'm writing hello world, okay, into the first argument. So I'm writing hello world into the response writer. So what happened basically, it will just return the hello world back to whoever called me. It's kind of weird because usually I'm expecting to see like server or response.write or response.send, but the way that Go is doing it, it's using this IO library, and then using the write string to write into the and yeah, there's something to do with interfaces that I didn't. This is a little more advanced topic that we can talk about later, but there's some interfaces that are taking care of some of the things here. I don't want to elaborate right now, but just want to show you how it works. And this is just to listen to port 3000. So let us run it. So I don't know if you know about in Vim, you can do Control Z. It's not Vim, it's a Linux feature. Control Z, and now it goes to the background. The application that we were running before, our Vim. And if I do FG, it's going to move back to the foreground. So it's pretty cool that you can do Control Z and then go back. Let's do Control Z and then go build. Let's build our. Okay. Cancel package GitHub. No, build Go source. Maybe go. No, I don't know. Yeah, there's something with our workspace. It's probably not configured properly. I think so. Copy the Go source file.
Okay.
Oh, we didn't save it. We didn't save it. Okay. Now I'm gonna do FG. That was actually pretty legit. It told me that you can't find any file, and now I should have a binary. Let's run it. And I wonder if I have something running on port 3000 and it's on the server. I might have something. Let's see. Notice that the name of the binary is always a folder name. In this case, it's hello. Okay, it clearly didn't work because maybe the port didn't taken. Let's do 6000.
I think you have to build again, right?
What happened? Yeah, you're right. Okay. And let's try to hit our server. I can do it with curl, or I can go to the browser. Let's go to the browser. I think I have a domain. No, let's hit the IP. You guys remember the IP of the server?
It's a local host.
Yeah.
Oh, I want to hit it from the outside world, actually, just for fun. But you're right, let's start from localhost. Why am I going crazy? Let's go and open here. Let's 6,000.
Oh.
Ooh, hello world, guys. We kind of achieved half of our goal. We wrote a web service in Go.
Cool.
So yeah, so that's the simplest web service ever. Doesn't do anything, but it works and it's always very, very fast. It's almost as fast as Java, and it's actually getting better every release. The garbage collector is not as good as Java garbage collector, so if you're doing something crazy, it might not be as great, but it's very good. And Google themselves are replacing a lot of their internal services that used to be written in Go, in C++ and C in Go. Actually, download.google.com, the site that you go, the API that you go to, or endpoint to download a bunch of stuff, like a bunch of.
Can we look at the binary, see what it looks like? To do a more on that file. That's it. Not a text file. Okay.
Yeah, it's a 64-bit LSB.
So why do you think the Go is going to replace Node.js?
Oh, because it's way more maintainable. It's very, very easy to write concurrent applications. I'll show you a different application. Actually, I don't have it on this one.
How much library support do you have? Node.js, there's like all the, through NPM, you can download so many different packages that others have developed, right? Does Go have a similar structure?
Yeah. So this is the standard library. For example, we were dealing right now with the, and by the way, my Vim plugin that I have, next time I'll show you, I can go right away to the doc of anytime I stand on a function, it will go and find it online. Pretty cool. But that's pretty nice library. It comes with a lot of things like FMTs formatting. Where's the I/O? So yeah, there's a lot of libraries people create as well. So you have WebSockets. If you need WebSockets, you have built-in templating. So if you want to build a site that is like, and we can do it maybe next time if you guys want to build a complete website. Let's say you want to render site server to render on the server the HTML, you can do it with Go with the built-in packages. Also, there's testing built in, very easy to test. You just run Go test and it will run all your tests. See overview. Package I/O provide basic interface I/O primitives. Yeah. You need to learn how to read their docs, but after you get the idea, it's pretty cool. I think write string. Did we use write string? Yeah, we did. Let's see what write string that we just used it. Okay. Interesting example. So notice that here, it's not even a web service, right? How cool is that? It's the same exact function that knows to use the stdio out, right? And in our case, we send what? A response writer, but both work. Why is it working? Because of interfaces. And let's see if I can see what it is. The write string. Write string. So it tells me, okay, it accepts a writer and a string. Okay, so this is supposed to be a writer. Interesting. What is a writer? We'll see in a second. Okay, but I think it's an interface. And good question is, what is an interface, right? And how is it different than Java interface? And you'll see it's something pretty cool. That makes you write code that is very, very nice and reusable. And this is the return value. Notice that you can return multiple return values. In this case, I'm returning an integer. And this is probably how many bytes? Let's see. Write string writes the content of the string S. So it writes the content of the second argument to the writer, which accepts a slice of bytes. Slice is like an array, basically. You can think about slice as an array, so array of bytes. If the writer implements a write string method, okay, so as long as this guy implements this write string method, it's invoked directly. Oh, okay, never mind. But yeah, so we can return two values, multiple values, more than two, I guess, in Go. Let's see what writer is, because that's interesting. So it says type writer, and it's an interface. So basically, anybody in your code, including your own code, that implements a function called write with this signature, you can use it. You can use it whenever you have to pass it as a first argument of write string, right? So I guess response writer probably implements this function. Therefore, he implements the interface. That's a beautiful thing. In Java, you have to define it. You have to like extend the interface, right? You have to explicitly say what's the interface, right? In Go, as long as the function adhere to the signature that is required, that's it. It's an interface. So it needs to have accept an array or a slice of bytes, and you need to return int and error, and that's it. So probably both, right? In the example that we read, this one. So I guess this guy, stdout, is also just like our response writer. It implements the interface, right? And we can check it out. Let's go to OS stdout and see.
Hey, can you, Oren, can you, change the first parameter to something that doesn't implement that? I want to see if it gives a compilation error or if it will give a runtime error.
All right, let's do it. Just change it to R by accident, right? Go build. Okay, do not use R. Why? Because R is type of request.
Right.
It's a type I/O writer, which is great. Like in Node.js, I would find those issues on runtime, right? In Go, just like Java, you find it on compilation time.
Right. Yeah, it's kind of like the templates in C++, right? Where a type that you specify, if it has the right method and the right signature, it'll compile. If not, it'll give an error. It's kind of similar to that.
Yeah,
that's cool. It's cool.
Yeah, very cool. So yes, we learned a little bit about interfaces, which is nice. And there's a place to see like other people packages, which and all the documentation. Every time you write also Go code, you can run a command go doc, and it will create documentation for you. Go doc or go doc dot. Let me have it in my documentation. Let me see. Go doc. Where's the doc? Oh, I don't remember, but there's a command that you can run, and it will create a documentation for you in a nice kind of formatting, just like the official docs. In here, godocs.org, yeah, I can find other people's packages. Let's say I want to find WebSockets. So this is some of the Gorilla's pretty famous WebSockets library, right? And it tells me, okay, here's the function, the function. Yeah, need to read this stuff, but you know, it's all there. The community is pretty big. Maybe before I'm gonna conclude the session, I want to show you another way to write an HTTP server. Instead of an anonymous function, I'm going to use the named function. So let's look at this again, right? This is an anonymous function, right? The second argument. This guy doesn't have a name. This is the func.
Right.
Now let's go and call it hello. So web service 2. Okay, and let's change it to 6,000 again. Now let's what's the difference is? I'm using this handled function. I'm passing the first argument, which is a string, right? And it can be like whatever I want, right? It doesn't have to be the root. And then I pass a function handler to this guy, right? Other than this, it's the same code, exactly. I just don't use an anonymous function anymore. Let's build it. Let's do run. And let's go and make sure it works. Cool. So yeah, I think that's good for the first session. What do you guys think?
Yeah, good.
Cool. So I guess.
Do you have a code example of that channel, using a channel to communicate between two threads?
Yeah.
You don't have to code it, but if you have an example, could you show it?
Yeah. I'll show you a code that I wrote recently, actually. Actually, let's go to Go tour. It's pretty cool. Let's look for, or Go by example. Go by. That's a great way to learn Go. Also using this guy here, right? And you can go through like slowly. Okay, hello world. You know, you start here. You can see a nice explanation on the side. You can click on this guy here to actually run the code. And you can also share the code here with other people. You can click on the share button and create a URL for you. You can go different examples here. Let's go back, and I want to show you the concept of channels. Okay. Channels are pipes that connect concurrent Go routines. You can send values into channels from one Go routine and receive those values into another Go routine. I think it was inspired by what other language using it? Is it Erlang maybe? I'm not sure where's the inspiration for this, but the guys who built it, and specifically Rob Pike, one of the authors of Go, he took inspiration from multiple languages and he kind of like picked the good parts from different languages. And I can't remember the exact. There's also a very famous C book that the same author wrote the Go book. Go programming language. Yeah. I bought it to my coworker, Go programming language. So if you guys know the famous author that wrote the C book.
Oh, Connie and Richie? No.
Yeah, exactly. So Carnegie here, he wrote this book recently.
Oh.
Well, I haven't finished. I just started reading this stuff, but one of the episodes, one of the chapters, the first one, it talks about the inspiration for Go. Yeah, that's kind of like a great book to start with, I think. So yeah, let's go back to channels, and now we have, let's see here, package main, fmt, message, make channel. So I'm creating this channel, and there's a keyword called make. You need to use it once in a while for certain things in the language. One of them is channels. called the channel, and the channel of strings, right? And this little thing here is go func. That's the way to create concurrency in Go. To use this Go keyword. That's it. It's 3 keystrokes, right? Go and then space, and then you call your function, right? In this case, I'm calling anonymous function, and all I'm doing here, I'm sending the string ping, and this operator, I'm shoving it into my message. And look at the arrow; it's to the left. It means I want to shove this into this pipe. As soon as I'm doing this, this code will be executed. So this code will not be called unless, boom, you get this guy here shoving into the message. So by doing this, I'm communicating, I'm sending the ping into the main Go routine. The main itself is a Go routine as well. Just an implicit Go routine. Right? Let's run it. Go run. I need to do it here. Terminal. Let's run.
What is MSG there? What is that?
Where do you see MSG?
Yeah, in the previous code example that you showed.
Oh, this?
Yeah.
Sorry. It's just the name of variable. Go, you don't have to declare. You don't have to define the types. You can do var. Var MSG string. You can define it like with a var keyword, but you can have it's called type inference. Go infer the type. Infer that, oh, this is probably a channel, and this is probably a string, right? So it's kind of like helps you to write more concise code, compared to Java or C. So that's a common thing to do: colon, and then equal sign. So that's a simple example, right? Nothing really happened. I'm launching this guy. It's a Go routine. I can launch millions of those. Go over my tasks and run them concurrently, and then communicate back with this, right? Let's see more of the channels or Go routines. This was a Go routine, right? Oh wait, I jumped to channels. Let's see the Go routines one. Go routine is a lightweight thread, right? So here, what's going on here? I have some function calling f direct. Okay. And then I'm calling it go routine. Interesting. So here I'm calling it without calling it Go routine, right? On the same thread. Here I'm running it in a separate thread. And go, and this is an example that I can do it, I guess, anonymous function. I guess. Input. Yeah, I'm not sure what I'm doing here. Oh, this is scan. I guess it requires to hit a key to finish the program. That's a scan command, I guess, a scan function, but that doesn't really matter. But yeah, it is showing you that you can run something in a Go routine. That's all the example is doing. And yeah, there's like a buffered channel and non-buffered channel. So number 2 here, I can say that my buffer has space for 2 elements. So only when there's 2, then actually I can't remember what the buffer is doing. It will only accept and send if there's a corresponding receive. Buffer channel accepts a limited number of values without a corresponding receiver for those value. So I guess I can shove 2 elements in this buffer. So I'm shoving it, another one, and then the second one, and then it will print them. So there's two different types of channels. How to synchronize between channels. Let's see this guy. Let's just run it. It might be easier for us to see. Working. Yeah, nothing really happened. It just said done. But let's see. So I have this worker guy, right, in the main. First, I'm creating my channel, right? I call the channel done. And now I'm passing the channel into my worker. So my worker is going to create because it has the Go keyword, right? It's going to run in a separate thread. This guy. It will sleep. But it doesn't have to be sleep. It can be anything that is CPU intensive. You don't want to block your main thread, right? And when you're done, you're just calling this. You're shoving the true into the done. And guess what? Then your program will exit because Go will wait. So basically, you can run multiple of those, and just at the end, you shove this guy into this channel, and then I guess here, yeah, it is blocked until it receives the message, and then it's getting more and more crazy. But synchronize direction, select.
Cool, man.
Yeah.
I think we should take a look. So there was another site you showed, right? Go by example. Prior to that, you had another place where you can go and type in code and run it. What was that?
Yeah. So if you go to Golang, I think it's from the Golang site. You can click on, let's see, documentation, run, share, tour. You click on the tour. Right?
Oh, tour. Go tour. Okay.
Go tour. Yeah. And also, if you go to documentation here, pretty nice, like a learning Go. So you can start. Okay, start with a tour, and then how to write Go code. There's like what's the kind of like idiomatic Go, right? Workspaces that we talked about earlier, right? You have the if I do Go, if I run Go get, it will get all the different imports that are there, even from other like people's code on GitHub, and it will put it in the right place. It will put it in src, and then the GitHub, and it will put everything in the right place in your workspace. That's important to read, basically how to write Go code. And then let's continue here. Effective Go. That's also very, very great to kind of. I didn't read the whole thing, but I constantly go there back, and it's pretty cool that you have a language you can actually read this page, and you kind of understand most of the stuff about the language. Formatting, so how to comment. Now packages. Remember that we used package main. If I have a library, I can use. Let's say I have a search library. I can use package search, and then everything it will be have at the beginning of the file, the name package search will be its own library. It's kind of like a namespace. And then if I want to access something that exists in different package, I need to use like the package name. I can do search.foo. And the capitalization matters. If I have foo as uppercase, only then it will be available for me to use from other packages. So if I'm in package main and I want to access the foo, whatever foo is, it's a function or whatever, foo has to be capitalized, which is kind of weird. You're not used to it, but the capitalization matters on the visibility of the variables. Effective Go is also. Did I mention effective Go? Yeah, I did mention it, right? Yeah, it's important to read. FAQ, Go Wiki. That's the package documentation that I think we kind of like looked at before. Language specification is also a page that you sometimes need to read once in a while. It's pretty cool to see the spec. It's very kind of like a concise specification. What are the characters? I want to show you the keywords, for example. It's pretty cool. There's only a few keywords here. That's it. Right? That's the number of keywords in the language. I think it's 25. And that's pretty cool. Select. You can use it for channels, I think. There's an explanation in the Go by example how to use it. That's the operators. So yeah, that's the spec. Language specification, the memory model. Let's see what's going on here. I don't think I've actually looked into this. Memory model and Go. Locking. You have mutexes. You don't have to use channels. If you want to go a little lower level, you can do locking if you want. So you can lock something that you want to protect. You want to protect something in this function, right? So you lock it, and then I guess you unlock it here. So you say you want to protect A. So you lock it, and then you call it in a Go routine, right? Because you want to maybe not to block the entire thing, and you unlock when you finished using it, right? You finished writing to A. So you can use mutexes if you want, but depending on your use case. Sometimes channels are not fast enough for you because you're doing something, requires a. Yeah, that's basically it. There's more, obviously, but I think there's a great videos if you guys are into YouTube, Golang. It's a guy that likes to teach. Oh, that's a great video. Oh my God, that's an amazing video.
Yeah.
50 minutes. It tells you everything you need to know about Go.
Tutorial about Go. Well, basically, Go brings together the best of 32 and 64-bit as well. You can see how it comes
Yeah.
with the.
That's a great video to start with.
Able to do drive L.
Everything that they're kind of like the basis of the language,
Print, air, complicated, or people make it way more complicated.
Okay.
You got it. Sorry. Cool. So I think we'll conclude the session. We did about an hour, except for the half an hour at the beginning that we had issues. But let me stop the sharing. Cool. Oh, we lost somebody. Hey, Sean. I think we were 4 originally. All right, guys.
Yeah.
Thank you guys for. Is there anything else that you guys want to know, or we're good for now?
Hello?
Hey.
Yeah, thank you very much. My kid is like crying, so I had to handle that.
All right, guys.
But this was awesome. Thank you so much. I'll check it out.
Yeah, we can do it maybe next week if we want, or whenever.
Okay, cool.
Cheers.
Awesome. Thank you.